I want to talk a little bit about some of the practical implications of p-values and significance levels. So this quote is from Gary Kasparov. He's the chairman of the Human Rights Foundation, and he posted this on Twitter about the time that the Johnson & Johnson vaccine was paused for a short time. So he said, pausing a vital vaccine during a pandemic over a 1 in a million risk isn't leading with science unless you don't know statistics is also a science. It's a terrible blow to public confidence that will cost lives. So what he's getting at here is that a 1 in a million risk is super minuscule. Yes, there is a risk, but that is very, very small. If this was something like a 1 in 100 risk, then absolutely we would be pausing the vaccine. But a 1 in a million risk is a pretty small issue. And to pause this and make people doubt that could undermine people's opinion of the vaccine. So he went on to say, it's a war. There are risks you take to save many more lives. Pretending you can eliminate all risk is telling people what they want to hear instead of doing what must be done. And this is the crux of leadership, of science, of many things in life. And that is there's no 100% guarantee. You can't turn that risk to exactly zero. You can get it very close to zero, but there are still always going to be those outliers or flukes or something that happens that's just the variation of life. And so you have to decide and weigh that. At what point do you say, yes, this is a lot of people we're impacting, we need to pause this vaccine, versus this is a really low risk and maybe we can do something better to screen people, right? So there's, this balance that you have to achieve here. And I'm not saying whether they made the right or wrong decision at all. This is not my area of expertise. I'm not a doctor. But what I can tell you is about what statistics means in general. And what statistics means in general is that you're never going to eliminate every single possible risk. So you have to decide where to draw that line in terms of acceptable risk and unacceptable risk. So the way that we do that is with our significance level. We draw the line of acceptable and unacceptable risk by whether we reject or do not reject. So the most common significance levels are alpha of a 1%, 5%, or 10%. The alpha or the significance level always has to be set prior to analyzing the data. So typically medical or safety issues will use 0.05 or 0.01. Occasionally people that are extremely concerned about not making a mistake will use an alpha of 0.001, but I haven't seen that done a whole lot. Now, on the other side, if it's not a big deal, so maybe we're interested in the proportion of students at Western who love Hawaiian pizza, that's not a big deal. It's not life-threatening if we get it wrong. Some researchers might opt to go out to a 10% alpha on that because it's not as critical. If no significance level is given, we'll always use an alpha of 5% as our default in this class. So I want to talk about what these significance levels actually mean. So if the probability of an observed difference by chance is 1 in 20 or less, the difference is statistically significant at the 5% level. So if you're using a 5% significance level, what you're talking about is a 1 in 20 chance. If you switch to a 1% significance level, what you're talking about is a 1 in 100 chance. All right, so let's see where you would set the significance level for each of these. The researcher claims the proportion of college students who hold part-time jobs now is higher than the proportion known to hold such jobs a decade ago. Would you be willing to believe this claim and reject the null hypothesis if we use an alpha level of 0.10? So I would say, yeah, this is an important issue, keeping track of where, how many college students are working and maybe how that's impacting their life balance or their grades or things like that. But this isn't life critical. So I would be okay on this one with an alpha of 10%. This next one, an engineer claims that the proportion of rivets holding the wing on an airplane that are likely to fail is below the proportion at which the wing would fall off. What p-value would be small enough to get you to fly on that plane? Definitely a 1%. If we can make it smaller than that, that's where I want to be. I'm not willing to accept a 1 in 10 risk here or a 1 in 20 risk that that wing is going to fall off the airplane, right? So something like this, it's really critical. We're going to set that alpha level a lot smaller so that we can make sure that we're keeping people safe. Okay, so one thing I do want to note, there's a little note at the bottom here, and this is that anytime you're giving a conclusion from your research, you should always state the p-value. So you'll hear some people say, oh, my results are statistically significant. And maybe they are, but for me, I want my reader to be informed. So even though I'll say I had statistically significant results, I'll always state that p-value because I'm giving the greatest amount of information possible so that person can evaluate the risk to themselves and how their perception is of where that should be.